We want to find a state variable model for this active circuit and plot its step response using MATLAB. Anytime I'm creating a state variable model, I need to define states. My only energy storage element is a capacitor, so I'll choose a state as the voltage across the capacitor, x1. Current through the capacitor is the capacitance, 0.5, times the derivative of the voltage with respect to time, which is x1 dot. Now I just need to rely on my op-amp rules, KVL, KCL, and Ohm's law. If I call this my reference voltage, 0 volts, this is also 0 volts since there's no voltage difference across the terminals of an ideal op-amp. Now let me call this node A, and if I do KCL at A, the current entering that node is U of t minus 0 over 2 ohms, and that's equal to the currents leaving the node. The current through the capacitor is 0.5 times x1 dot. The current through this resistor is x1 over 4 ohms. If I solve this for x1 dot, multiplying through by 2, x1 dot is equal to U minus x1 over 2. There's my first and only state equation. Now I need an output equation. The voltage difference across here, 0 volts minus y, is the same as x1. So y is equal to the negative of x1. If I write that in matrix form, so y is equal to c times x plus d times u. So y is equal to negative 1 times x1, which is my vector of state variables, plus 0 times u. So c is equal to negative 1, d is equal to 0, a is equal to negative 1/2, and b is equal to 1. There's my state variable model. Now let me check to see if this model actually makes sense before I simulate the step response. So let's look at a constant input where U of t is equal to 1 volt for t greater than 0, and see what happens as t goes to infinity. As t goes to infinity, for a constant input, the capacitor should look like an open circuit. So this circuit becomes an inverting voltage amplifier with a gain of 2. So y of infinity is equal to negative 2 times u of infinity, which is 1 volt, which becomes negative 2 volts. From the equation, if I look at this equation as t goes to infinity for a constant input, x1 dot, the derivatives go to 0, so u is equal to x1 over 2. So x1 is equal to 2 times u. If u is 1 volt, x1 of infinity is equal to 2 volts. Y is equal to the negative of x1, so y of infinity is equal to negative 2 volts. The equations agree with what I'd expect, so it looks like I've got a legitimate state variable model. Now I'm going to go into MATLAB and simulate the step response. This is a really simple problem, so I'll just do it at the command prompt. A is equal to negative 0.5, B is equal to 1, C is equal to negative 1, and D is equal to 0. I can create a system model. Sys is equal to SS for a state space model of A, comma, B, comma, C, comma, D. And to calculate a step response, I can use the step command, step of sys. We'll calculate the step response, open a figure window, and plot it. This looks reasonable. Starts out at an initial condition of 0, which all step responses will. It goes down to negative 2, which we calculated as our expected final value, and it looks like the response of a first-order system. So this seems very reasonable, and I'm happy with it.